Am I going to have to separate y'all? Avery will probably say yes. Brian has to move. All right, let's factor what we can. Take out 2x on the top. It leaves me with x squared minus 1. Take out
4x squared. X squared? Wait, it's x minus 5.
Oh, sorry.
It's okay.
Sorry.
X squared minus.
Difference of squares. So I got x minus 1. That's exactly right. Now everything's factored completely, and let's start marking out what we can where we can. That's right. So I'm going to take out 1x, and then 2 divided by 4 is 1/2. So I end up with, ooh, there's nothing on top, but there really is something on top. It's 1. And then I have 2x, x plus 1.
Number 6.
Yep.
Yeah, that's what I got.
Which opposite sign thing?
X minus 4.
Oh, taking out a -1. I gotcha. You recognize that you were supposed to do it, but you just didn't know how to do it. Okay. Is there one on here that happened with? Okay. Okay. I will. All right, what else before? How about 1 through 3? Anything else from 1 through 3? 3? 1 through 3, Brian. 2k squared minus 5k minus 3 over k cubed minus 27. I lied. I don't like this. Okay. Factoring here up top. What multiplies to -6 but adds to -5? -6 and +1. So this is going to have to be a slasher, guys. It's a slasher. And this is a difference of cubes, which is little parenthesis, big parenthesis, same change plus. Okay, I'm just going to go ahead and do this since I'm already here. 3k and 9. All right, slash the top. I end up, take out a 2k. I'm left with k minus 3. Take out uno, k minus 3. I have k minus 3. K squared plus 3k plus 9. That's right. K minus 3, 2k plus 1, k minus 3, k squared plus 3k plus 9. Now, can I factor that trinomial any further? Never. Why never? It was the second half of a cube. There's 2 cubes because they're not. It'll never factor for you.
I didn't even consider that I could factor out. I didn't either. I went to the next problem. I'm done.
What else? 5.
I want to know. Do you know what all the answers are? Like, do you have
I don't have it right now, but I can pull it.
I just want to know, like, if I got them right, then I probably would be possible.
Okay. So it will be beneficial for y'all to have the solution so you can check your work like that. And check and see what you did. Okay. I always do that for calculus. I just don't ever think that for calculus, but I will. I'll do that for y'all. Just for y'all. You're welcome. Okay, well, y'all ready to add and subtract? Oh, okay. Y'all all sit this way. No, not the practice, just the, we'll do the practice together, but the second page is from it. Yes. Hey, Kenzie's got a sweater vest today too. I told her I didn't like it. I'm just not a fan. I don't like the sweater vest trend. I think because whenever we were that age, it was. I had several sweater vests. I had printed like ones with like designs on them and stuff. It's very trendy though. No, I said I don't like sweater vests. It's just I'm not a fan of that trend. Okay. Do you have a shacket too?
I don't have a shacket. I didn't know what the word. I didn't know what that meant.
Silliest thing I've ever heard in my life.
Told me what a shacket was. What is a shacket? It's a
Shirt jacket. Like a lined flannel.
Or you can wear it over a shirt. No, it's a shirt that you can wear. Just call it flannel.
Like a flannel or a corduroy that's lined, that's like a little thicker, that's like a. It's a shirt jacket. It's a jacket. It's a shirt you wear as a jacket.
An overshirt. It's still just a shirt. You just had it on over another shirt.
All right, let's start basic. You gotta have a common denominator. Does it? So, I guess my question then to you is, how do you come up with a common denominator? Denominator. Okay, that's what I was trying to get you to. There's a difference in a common denominator and a least common denominator, right? They could be the same, but they're not always the same. Least common denominator is what we really want. And what that really is a least common multiple. Yeah, right? Y'all remember doing that? Yeah. Are y'all with me? So, like, the multiples of 3, 6, 2, 3, 9. I'm going to stop there because this is, right, least common multiples. And I'm showing you this for a reason. I know this is basic, but you don't really think about it anymore. You just kind of do it. Or I don't guess you do. And then, you simplify in the end. So this denominator would be 3 times, or the LCD would be 3 times 7. And you give it what it's missing, right? This needs to be multiplied by 7. I do it to the top and bottom. This needs to be multiplied by 3. I do it to the top and bottom. Okay. And then I just have to combine the tops and put them over that same base, right? That's exactly what we're going to be doing. So, but we're not going to list the multiples out like this. Great day. Let me just show you. Y'all good? Look at like number 7.
Times 5.
Why aren't you timesing by W? Why aren't you just multiplying the bases together though? It's already there. It's already there, right? So the least common denominator here, remember it's a least common multiple, so each entire denominator has to be included in the, does that make sense? Like if this looked like this, my least common denominator would have to have 2 W's in it. Because every denominator has to be completely included in the least common denominator. Okay, so we said the least common denominator here is 20W, or 4 times 5 times W. Now, one way that I tell students to look at it, this is 4 times W, this is 5 times W. Write the first denominator, 4W, 4 times W, and give whatever's missing from this one that it doesn't have. So does it have a 5? No. Does it have a W? Yes, it has a W. I don't need that again. So that's the least common denominator. Y'all are looking like you are crazy. This will make more sense on why I say this whenever we get to the actual factors, like the x plus 2, the x plus 5. Joyce, don't make fun of me. I hurt my feelings. Everybody was just kind of going. I'm overcomplicating it, but for a reason. Okay. I'm going to give this one a 5. Thank you, Stella. Appreciate that. And this one a 4. And so I have 15 over 20W minus 8 over 20W. Let's crank it up.
Number 8.
Numero 8.
Oh, wow.
This one's easy. We probably don't even need to do this one. Okay, what's the LCD? X plus 4. The first one's good. Right? Now, all right, 2x minus 1 minus, be careful of these subtractions, right? This is minus 3 times x plus 4. Now, here's what you're going to have to do whenever you add or subtract. Once you combine, you're going to leave the denominator alone. But the numerator, you're going to have to expand and then simplify. The reason is, or I can't start scratching things out because all of my plus or minuses look up top. They're not enclosed in parentheses anymore, and I'm going to have to simplify this. So before I can simplify, I'm going to have to kind of expand it out and then shrink it back down, and then I can simplify. Let me show you what I'm talking about. Up top, I can't combine anything the way it is right now, right? But if I FOIL, or if I distribute this, minus 3x minus 12. Now I can kind of condense it back down, right? I've got some like terms. I get negative x. Now I want to look to see if I can simplify it. Can you? I don't know. You tell me.
I think it's a negative and a
Sure you can. If you want to kill a kitten.
No, I don't want to kill a kitten.
You can't.
It's because it's
The whole thing. It's they have to be in parentheses. So I've got two factors like this, so no, it's completely simplified. They wanted to okay, Stella wanted to cancel out the x's.
Okay.
And so we said, no, you can't, because you can only cancel when all your plus or minuses are in parentheses. And at the time, they're not in parentheses. So the only thing I could cancel out was another negative x minus 13 or an x plus 4. And I don't have those top and bottom. So I stop and I'm done. Okay. With no crumbs. No crumbs! Okay. Let's look at number 9. We get progressively harder here. Is that a plus or a minus? There's a little something on my paper. Right over the sign. All right. Now,
It's R minus 5. No, R5. You got a factor.
You got a factor. Good job. This is actually R minus 5, R plus 5. So what's my LCD? What's my least common denominator? R minus 5, R plus 5. Oh, dang, why'd they give us this? Yeah, you can. Oh. This is actually a really easy one then. Okay.
So then it's 6 over R minus 5?
So then it's 1 over R minus 5 plus 6 over R minus 5, which is 7 over R minus 5. You don't have to, no. We could have gone through and I could have given this an R plus 5 top and bottom and then simplified down. Is that what you were going to ask? Right.
So if it's like that, you have to break it down first. And then
If you can simplify before you start, it's always easier. It'll always make your life easier. Yeah. Yes, absolutely. Factor is the key to all these. Yes. Yeah. Let's look at number 10. 10's a better one. 5a plus 6 over a squared minus 4. Ruh-roh, I see. Look at you! Look at you! No crumbs. Yeah, a minus 2a plus 2. Yeah. Nothing cancels. So I'm ready for my LCD, yes? What is the LCD? Yeah. First one's good. What's the second one need? Now I'm ready to combine numerators over the common denominator. So 5a plus 6 minus, I always do this in parentheses this way because I want to make sure I pick that minus sign up because everything's being subtracted, over a minus 2. Don't start multiplying the bottom back out. You're going to undo the work you did to get it like that. Look at the top. Now I have 5a plus 6 minus a plus 2. Don't cancel out until all the plus or minuses are in parentheses. We got to put them there.
Can we not cancel a minus 2 and a 22?
No. Because
Is it because the one's attached to it?
those aren't in parentheses. You are.
You are. Oh, wait, how?
Because you got everything up top must be nothing more than a multiplication problem. And right now I've got a lot of adding and subtracting. I have to have this plus these two signs are not in parentheses. In order to cancel anything out, they're going to have to be inside a set of parentheses. Okay, so look at the difference in the R plus 5 one. This was an entire top, so I can put parentheses around the entire top. There's not any plus or minus that's outside of parentheses. So you can always parenthesize the whole thing.
Yeah.
But you can't just willy-nilly put parentheses if you want to.
So even though the 8 minus 2 in parentheses already.
Correct. Because all of them have to be in parentheses.
Okay.
Which a plus 2? So every denominator has to have both of those. The first one already had them. The second one only had one of them, but it needed the second one, so I gave it the second. Yeah. Both bottoms have to look exactly like the LCD. Okay. So now up top I have 4a plus 8 over. Absolutely. What can you take out of it? Bigger. Now look what happens. Now you can cancel because now all the pluses or minuses are enclosed. See the difference here? What happened? So last steps.
Let's be real, people. You're not going to mess it up.
Okay. I have to use it more whenever I use it, yeah. But I love it. Really? I have some unscented ones at home. I'll switch. I haven't opened all my advent calendar ones yet though, so yeah, I have 12 of them. Okay.
Wait, 12 advent calendars or 12?
12 doors to open. I've only opened 2.
I thought you said 12 advent calendars.
No.
I was like, that doesn't look like that.
We like birds. Okay. Let's look at 11 and then I'll let you try. Q plus 1. What? Stella will wipe your tears for you. No, I'm just kidding. Don't cry. Just don't cry. Okay, turn the other way. Aaron will wipe your tears for you. Tell me what to do. I'm going to try this one on your own and then we'll do it together. Parentheses. Because I wanted to make, what I essentially did was I changed this to a plus and put a -1 in front. To make sure that I subtracted everything in that second parenthesis. Because when you're subtracting, what happens, you've got this first one, right? And so which was actually, it's actually 2 pieces, it's all of these. So you had Q minus 3, Q plus 1, and then you had to subtract everything in that second one. So you had to subtract Q minus 1. So what I did was, instead of doing that, I just said plus -1 here and distributed a -1 through.
Not like Q minus 1, Q minus 1 bottom. No, that would miss what you just did.
Right, right.
Stupid question. I figured it out. So I just have to. Okay, how do I?
I'm losing my mind.
I can feel my brain in my head. Is it 1 over x squared and 5x? I can feel it. Wait. I feel like I have this in mind.
Isn't this fun? That's what I got. Is that what you got? What? Never, ever, ever do that. Always, once it's, don't throw her under the bus.
I didn't know where to go either.
Once it's factored completely, leave it alone. Yeah.
multiply it together and just put brackets.
So if you have a problem like this, you just do the thing, multiply the other thing by
You could, but you should come back to the same thing.
if you've gone through, it wouldn't be like x squared. If you wouldn't FOIL
The bottom, no, don't FOIL the bottom.
is that 11?
You won't ever, yes. No, it's 12.
I almost had a heart attack. I was like,
You won't ever, listen y'all, as you go through this, you will never touch the bottom again until you go to simplify at the very end. You're only working in the top just to get it factored. That's the whole goal, is to get everything completely factored. The bottom's already factored completely. You did that when you found the LCD.
could I just multiply what's 5x minus 6? And then that would be
X plus 6.
I know. And then that would be
Say it again, multiply by what?
5x minus 1.
Mm-hmm. No, because that would have to change. It would have to be negative x minus 6 to be completely opposite. You're getting what we did yesterday confused with what we're doing now. I think you're trying to...
No, I'm just saying, like, if I could make it x plus 6. Okay,
I should put too much effort.
x minus 6. That'd be x.
X minus 6 times x plus 6 is x squared minus 36.
But then, wouldn't that be x squared minus 6?
Oh my god.
Where are you getting x squared from?
So look at the purple, what's in purple or blue or whatever color that is. You just combine the denominators here. So x plus 6 and x minus 1, and then you give it what it's missing. So it has the x plus 6, it's missing the x minus 1, that's why I give this one. The second one has the x minus 1, but it's missing the x plus 6, so I give it the x plus 6.
Oh my god, I just squared the cube. That's what I didn't want. Wait, why would so then what is it? Can you go back to the
I know how to do it.
All right, some of us have got it good and some. How does it just become x minus 1? Is that what you said? How does it just become x minus 1?
the denominator? Like, I don't get that. Okay. I know, yeah, okay. It's like, go back to the first example that we ever did, the times 3 and times 7. It's the same thing as that, but with things that we're doing.
So do you understand where the LCD came from?
What example? No, I don't understand. Really, that's 20. Why can't I just times it by 6 and then x minus where it's 21?
If you times this by 6, you're going to have 6x plus 36.
X minus 1, you times it by x plus 6. That's
Your bottoms have to look exactly the same. Because whenever you had 1/3 plus, what was it, 5/7 or something like that, to get these to look exactly the same, we had to multiply it by something to make them look the same, right? We have to force them to be the same. We said the same thing they need to look like is 21, right? Because that is 3 times 7 is 21.
Yeah.
It's already got a 3, so if I times it by 7, it'll now be 21. But if I do it to the bottom, I have to do it to the top. This one is already 7, but to make it 21, it needs the 3. But to do it to the bottom, I have to do it to the top.
You're adding something that
I'm multiplying by x minus 1. I'm taking the whole bottom and multiplying it by the factor that's missing. Oh my gosh. If you foiled it out, yes, but we're not going to foil it out. We're just going to leave it multiplied together.
Oh.
You see it now?
You're like, it's like a whole thing. thought you were getting x minus 1 from that fraction and then x plus 2 from that. Oh, I spoiled this one off. Okay,
Okay, let's do one more of these together. From your homework, though, flip it over. Let's do.
I'm done with one of them.
I don't know.
Yeah, we got complex fractions.
Oh, we're doing complex fractions. They're easier than the rest, but yeah.
Is that the answer?
Yeah.
Is that the answer?
This is 13 on the homework. Sorry. All right, I'm going to factor everything, and that's going to be my first step. 13 on the homework. So I'm going to make this r minus 3, r plus 3. And I'm going to make this one, what multiplies to 15 adds to 8, 3 and 5. So r plus 5, r plus 3. Least common denominator. Aaron, what is it? What it all together, what's my LCD though? R minus 3. Yes. That is correct. R minus 3, R plus 3. Then I jump over to this one. I need an R plus 5. I gave it to it. I need an R plus 3. It was already there, so I don't have to repeat it because I want the least amount. That's correct. So now I look. Who needs what? Wait. That's fine. We just shortcutted it because it had a 1 in the front. There was no leading coefficient. So we just, yeah. Whatever, when there's no leading coefficient, whatever multiplies to this and adds to this, those are the numbers that go there. But that only works when there's no leading coefficient in front. Otherwise, we would have to put it together, slash it, and do all that.
I've been doing the slashes this whole time.
That's fine. You can still do the slashes.
Yeah, but I just...
But if there's a coefficient, you have to take 3 years and do it. They didn't give us one. Get me one. Okay. Yes.
I got confused about like number 11, like on the nose.
Go ahead.
Is whatever you need to actually like distribute stuff. Like what do you distribute?
Only worry about distributing in the numerator.
Yeah, that's
Leave the denominator. Okay, so let's look at it. What do I need in the first fraction? The r plus 5. If I put it on the bottom, I have to put it on the top. This is going to be a distribute situation. Okay.
What confused me with the other thing was that it would have like r plus 1 or something. Would you distribute both of them, or is it just whatever's on the fraction? That's what we.
If it say that again, if it was like an r
If
plus
it was
5,
like r plus 1, would you distribute both?
you'd FOIL it. Yep. Yep. Why? Because I'm going to work with the numerators. I'm going to leave the denominators alone.
So even if it's like r plus 1, then
Yes. Yes.
because that's because I was like, there's no pressure.
Yes. So what does this one need?
R
R minus 3. What do you mean to all 3? Okay, you're not going to do that. You're just going to leave them like that. You're going to leave them written just like this. So don't make more work on yourself than what you need. The only thing you're working with is the after you get the LCD, the only thing you work with is the numerator. Yep. Then you just, so I've got r times r plus 5 minus 1 times r minus 3. And all this goes over my LCD. In fact, sometimes I'll just come here and do this and then plug it back in the end if you want to. But just to show you, it's literally, you don't even want to mess with it. You want to leave it. You start foiling, you're undoing the work you've already done. All right, now up top. Do you see why I cannot come here and just go that big minus right there? That's exactly why. Okay, so I'm going to have to clean it up before I can cancel out. All right, so distribute r squared plus 5r. Distribute minus r plus 3 all over. Again, I'm not messing with the bottom. Glad we saved this for day 2. What, bruh? What's wrong? Yes. If it's factorable and if you can, you want to go ahead and factor it. Madison, here's your shortcut again because the leading coefficient is 1. Okay. And this one I do have something that cancels. Now I'm good to cancel. Do you see why I can cancel now and I couldn't before? Okay. So now I'm going to go, okay. I like it. All a complex fraction is a fraction over a fraction. Okay? So here's what we're going to remember. We don't divide by fractions. What do we do? Multiply by the flip. That is exactly what we're going to do. So as we look at complex fractions, we're going to look at this as 3 separate problems. We're going to look at it as the top, and then we're going to simplify the top. Then we're going to put that out of our head for a minute, and we're going to look at the bottom, and we're going to simplify that as much as we can, put it out of our heads, and then we're going to take the top times, and we're going to flip the bottom. Okay? So we're going to approach this very simply. We're going to look at it as 3 separate problems. So addition, subtraction, division. That's exactly right, which is really multiplication. So look at like number 13, which gives you more practice with the addition, subtraction. But these tend to be not as complicated on the addition subtraction because they're complex fractions and there's 2 layers of them. 1/3 minus 1 over 2r. So this looks quite intimidating, right? You look at this and go, oh my gosh. But take it apart. So take it apart and go, okay, let's look at the top. Just the top. The top is 1/10 minus 9 over 40r squared. What is the... What? Oh, yes, y'all are jumping. Oh, my goodness. Y'all have got this. Y'all are... Okay, I was going to come over here and say the LCD here is 40r squared. So what do I need to give? Well, this is really like, I could say this is like 10 times 4 times r squared. So the 10's already in there. Think about your whole numbers the same way you would with any other numbers. Now, if you put 400r squared, you're just going to have more simplification in the end to do, and it's okay. Yes, it's okay. You're just going to, in the end, your fraction is going to need more work to simplify it than what. It's starting with a common denominator instead of a least common denominator. It'd be like instead of starting with 21, starting with like 63 or something, and then having to reduce down more in the end. Okay, I'm going to give this 4r squared. The second one's good. So I end up with 4r squared minus 9 over 40r squared. I want to make sure I simplify, factor all the way and simplify before I go any further. And in this case, that looks like what up top? Difference of 2 squares. So I'm going to say this is 2r minus 3, 2r plus 3, Every plus or minus is enclosed in parentheses. Ooh. I am going to box this and say that's the top, and I'm just going to leave it for right now. Walk away. And now I'm going to look at the bottom. The bottom, 1/3 minus 1 over 2r. What's the LCD? 6r. The first one needs a 2r. What's the second one need? The 3. So I have 2r minus 3 over, can I do anything else with it? Nope. That's the bottom. Now I'm just going to put them together. I'm going to do top. And remember, I factored everything. So I should just be able to multiply these across, cancel out. I shouldn't have to do anything else with them. So top, 2r minus 3, 2r plus 3, over 40r squared, times, and I'm going to flip that bottom over, 6r over 2r minus 3. And because we know multiplication problems, just straight across, you can cancel out 2r minus 3. Can you cancel anything else out? Sure?
Yeah. You are.
Take out an r. I would definitely take out an r. And then 6 over 40 reduces to 3 over 20. 2 goes into both of them. So I end up with 3, 2r plus 3, 20r. Yes, I divided both of them by 2. Just the bottom. So it's top times bottom flip. It just takes getting used to it.
Wait, so, okay, that's
I told you complex wouldn't be as bad as the other.
It's just, if you know the other stuff, you pretty much
You